Proof orchestration in Rust, scaling proof workflows. Thanks very much.
Thank you. Hi, I am Mohsen, and I'm going to talk about proof orchestration. So today we heard a lot about ZK VMs and how fast they become. We heard a lot of great news about how things are advancing. I was very excited to hear about that. This talk is going to be about how are we going to orchestrate the workflow. So we have this stream of blocks that are being generated very fast, every 12 seconds right now, and we want to generate proofs for them in a reliable way. So whatever happens from the moment that the block is created until it reaches the point to the consensus layer to say this block is valid, everything that happens in between needs to be managed by a piece of software. And that's basically the orchestrator that I'm going to talk about. So at Zircuit, we've been working on orchestrators for some time. It's been a bit more than 2 years. We have been running our workflows, our proving workflows in-house. And we have faced a bunch of challenges that we had to fix over time. And I'm just going to quickly go over that. So one of the challenges is basically being in time. Real time is not that important on L2, but when it comes to L1, we have this real time requirement that is in place. It's going to be difficult to do everything in real time. The workflow has to be elastic. It has to scale dynamically with the needs. So we heard about these gigantic blocks. Imagine if you have a lot of them that are being pushed at once or in a certain short period, then you need a lot more provers to actually deal with those amount of blocks that are coming in. The third one is my favorite, and that's why we're all gathered here today, is the innovation in the ZK space is moving very fast. Cool new stuff are coming in every day. So we need to build an orchestrator that can change with the pace that the space is moving. Another thing that we have seen in the production system when we run the orchestrator in production is basically the failure that is happening. Any piece in the system can fail. So a good system, a production system, need to be able to deal with failures. And the last one is basically being able to run on different hardware. So what are the requirements? I'm going to quickly go over that because of lack of time. We need something that can do any ZK VM or any prover that comes later. It has to be able to prioritize things when there is limited time. It needs to have built-in failover and be able to retry. Nothing can be forgotten, so you cannot have a request for approving that is lost or forgotten. It has to have distributed coordination, multi-network, scale horizontally, vertically, redundancy, failover. It has to be able to time out when it's needed. It has to be able to report how the progress is going, and it needs to do basically real-time proving. So what is the design? This is the part that I want everyone to take away from this talk. Basically, what we have designed is based on MapReduce, nothing new. The architecture itself is well battle-tested out there. So what you need to do, every piece of your proving pipeline has to become a dispatcher, so basically like map. So those shapes that you see over there, those are my steps that my prover needs to execute in order to compute a proof. Then for any step that needs to wait for other steps, so if you have a multi-step prover, like the sub-block idea that we heard from the SP1 talk, those sub-blocks need to be merged back together, and you need to compute a recursion proof over them. So that's where you basically need a collector to collect all the proofs that have been computed in the previous step. You want to make a new message out of that, and then you want to do an operation over that. So that's basically how the architecture works. In order to fulfill the other requirements that I mentioned, we worked on a basis of a message bus. So any communication that goes through this workflow of provers needs to go through a message bus. This has to conform to a trait. Right now, we have implemented it in NATs, but it could be implemented in any messaging or gossip-based protocol that you want to do. We are implementing it in traits. So what the message bus needs to do needs to be able to route work, and this could be inside the network you're running, could be outside the network, wherever you want to route it. So the message bus would be in charge of communication between all the services you are running. And then at the bottom, you have the workflow runner that decides what kind of workflow you want to execute. Well, let me just do a very quick example to take this point home. Basically, let's say I have the ZK VM X that has 3 steps. So I have a rectangle, I have a circle, and I have a triangle. In order to compute the proof that I'm supposed to compute, I need to do a rectangle and circle first. So those two can be executed in parallel. So that's what I'm going to do. I'm basically going to put 2 dispatchers together. So I have a dispatcher that starts carrying out the rectangle, a dispatcher that does the circle. Then I throw in a collector that waits for basically these 2 types of proof that I require. It would not finalize until the exact types 2 times as received, and then composes 1 message for me and forwards this message to the next component that is going to be my dispatcher and carrying out the final operation that in this case is the triangle operation. So as you can see, I can basically, with this flexible design that the orchestrator has, I can design any workflow that I need for my proving pipelines. So let's take this basically to ETH proofs. We were looking at the ETH proofs pipeline. So there are multiple provers, SP1, Hypercube, ZIS, RIS0, all different provers are running there. We don't have visibility on exactly how these VKVMs are being executed, what kind of hardware they are using. We hear about how many GPUs are used. We don't know exactly where they're being executed, but we try to imagine how this could be executed if we were to use actually our orchestrator. So the idea would be for any of those workflows that these provers have, we need to design using the orchestrator, the workflow that I explained to you. Each piece of this operation could be executed on various hardware. So basically, you could have a piece of your proving pipeline that sits on Kubernetes bare metal. You could have a piece of your operation that sits basically on AWS managed cluster, or you can have your spatial hardware or a machine or a cluster that has so many GPUs thrown at that. So even the internal steps of your prover could be broken down as long as all the pieces of the workflow can reach and dial one another through the message bus that we have. Everything should be basically manageable. So in the case of running the entire prover pipeline that you have on the same machine, it's going to be much easier, but still the same idea. So the entire prover sits on one machine. All pieces need to communicate. You break it down into dispatcher and collector, and basically you have everything together. So for this very example of ETH Proof's website, we have put together a demo. You can scan the QR code that you can see on the screen. This takes you to the orchestrator that we have put together, and you can see how the demo works. We haven't hooked it up with the provers in the background. It's just mock provers, but I'm going to show you how you can basically add any provers to this orchestrator that we have. Right now, the orchestrator, the way it's working, it expects an input that has to be in JSON format, an output, what is the output of the step, and basically if you put a binary inside the example that I showed you in the demo repository, you would be able to, if you put your prover inside with this input and output format that I showed you, your prover basically would be part of the orchestrator tool. So what are the takeaways? So what I showed you here is a universal proof orchestrator. It can run any provers on any infrastructure and any hardware, no limitation on the execution. It is battle tested. We have been using this prover in production for a bit more than 2 years for running our L2 proving needs. It has fault tolerant at its core. God knows how many times we had to wake up on call to fix some issue that was in the pipeline. So we have put all those lessons learned into the design already. It scales automatically. I showed you a mock demo of ETH proofs. You can scan the repository. You can take a look. What is on the repository? We have open sourced the images, so the binaries of the orchestrator are released, but we haven't released the source code. We plan to release the source code soon, and we are seeking ecosystem collaboration. Thank you very much.
Thanks so much, Mohsen. Final call for questions. I don't have any queued up. Very clear presentation.
Yeah.
Thank you.
Thank you.
All right.